welcome back to my channel Maths is Fun. Today we will be discussing with the chapter of similarity of triangles. Before discussing about the similarity of triangles, when two triangles are said to be similar, we have to know that. And what is the difference between similarity of triangles and congruency of two triangles? Now when we talk about congruency, two triangles are said to be congruent if they are similar in all respect. Okay, two triangles are said to be similar means they should be equal in size, equal in angles, every respect, means they should be mirror image of each other. Okay, like our hands palm of our hand, these two, right hand and left hand, both are same, so they are mirror image of each other. So like that time we can say that they are congruent to each other. Okay, two figures are said to be congruent if they are mirror image of each other. They are similar in all respect. But in case of similarity of triangles means two things: triangles or similarity of any object. Like if a child is wearing a t-shirt and his father is also wearing another t-shirt, of course their sizes will be different, but the same color, same size, same cutting of the t-shirt, isn't it? So the difference is what? About the size. So like that, similarity of triangles, similarity differs in, suppose this is 2, 2 and 2, and this is 4, 4 and 4. See, this is an equilateral triangle and this is also an equilateral triangle, but their sizes differ. Both are equilateral triangle. See, their sizes differ in a ratio, isn't it? 2 by 4. If we say that this is A, B, C and this is P, Q, R. So what will be AB by PQ? See, AB by PQ will be 2 by 4. That is 1 by 2. So the ABC triangles sides differ, or we can say we can compare them in a ratio of 1:2. AB by PQ is 1:2. So this is similarity of triangles. Similarity of triangles means they look similar in shape and size, but not size actually. They look similar, but they differ by the size. So what are two similar triangles? Two triangles are said to be similar if their corresponding angles are equal and corresponding sides are proportional. See here, the sides are proportional, all the sides, by 1:2, isn't it? Now let us know what are the conditions necessary for similarity of two triangles. Conditions necessary for similarity of two triangles. When two triangles are said to be similar, when there are few criteria like side angle side, there is angle property, angle property, and side property. So these are the criteria when in any two triangle, if you draw two triangles, suppose this angle is equals to this angle and this angle equals to this angle. Suppose this is x, this is y and this is y. So we say that x and y. So by angle property, these two triangles, suppose this is PQR and this is ABC. How do we write it? Triangle PQR is similar to triangle ABC. Similarity, this is the similarity sign. It is similar to, by angle property, these two triangles are similar. Now if the two triangles are similar, then we can say that their sides are proportional. Sides are proportional means, now generally people don't understand, students generally get confused that which side to be taken as for the proportionality, which side, like PQ comparison, we will compare with PQ to AB or AC or BC, which one? So now it's a very easy thing. See, we have seen here that this angle is x, and here in this triangle this angle is x. So obviously the angle which is equal is this angle, and its opposite side is which one? PR. So we will write it here as PR by, now it is equal to angle x. Here angle x is this one, and its opposite side is AC. So PR by AC. Since we have written PQR triangle first, in the numerator we have to write PQR triangle sides, and denominator we will write ABC triangle side. And which side we will consider? The angles which are equal, their opposite sides will be equal, corresponding opposite sides. If this angle is equal to this angle, then this angle's opposite side is PR, and this angle's opposite side is AC. So this will be equal to, now this is y and this is y here. This is y, and this angle's opposite side is PQ. So we will write it here as PQ by, this is y in this triangle, this one is y, angle A, and opposite side is BC. So PQ by BC. Now left angle, what is the angle left is this angle P. Angle P opposite side is QR, so we'll write QR by, and here the third angle is this one. This angle's opposite side is AB. So if you see that these three sides are already we have written, see PQ, PR, QR we have written, and also in this triangle also AC, AB, AC, BC, AB. Okay, so I hope you understood how to write this proportionate way. It's actually very important to know the corresponding sides and corresponding angles which are equal, and how do we write in the ratio form. After two triangles are similar, after we prove two triangles similar, which sides to be taken as this proportionate, which sides are proportional. Okay. So let us consider one question. In the given figure AB, see this figure, AB and DE are perpendiculars to BC. See, this is BC, this is perpendicular to BC, and DE is also perpendicular to BC. If AB equals to 9 centimeter, DE equals to 3, and AC equals to 24. This AC equals to 24. Calculate AD. AD means this much. Okay. So now, if we see the diagram, we have two triangles included in this. See, one is ABC, another is DEC. ABC full triangle and this smaller triangle DEC. So let us write solution. In triangle ABC and triangle DEC. In ABC, we see that angle B is 90 degree and here angle E is 90 degree. So what we will write? We will write as angle ABC equals to angle DEC, both 90 degree. It's given only in the question, right? Another one, what is common is this angle is common to both the triangles. See, angle C, angle ACB equals to angle DCE, isn't it? This angle DCE, common angle. So by angle criteria, by angle criteria, triangle ABC is similar to triangle DEC. Okay, triangle ABC is similar to triangle DEC. So as they are similar, then now we have to see the sides, we have to make the sides proportionate. Okay, now This angle's opposite side is AC. So AC will be equals AC by, this is 90 degree and in this triangle this is 90 degree. So this side is opposite means AC total, and this side opposite means DC. So AC by DC we will write equals to, again this angle, this angles, if we consider the total triangle, that means ABC. If this is the angle, then this angle's opposite side is AB. We will write it here as AB. And this angles, if we consider the triangle DEC, this angle C's opposite side is DE. Now which angle is left? This is angle A. Angle A's opposite side is BC. We will write as BC. Okay, and in the smaller triangle that is DEC, angle D is left, means this angle, and this angle's opposite side is EC. Okay, now in the question we are given AB's value, DE value, AC value, and we have to find out AD. So AB is given, DE is given, and AC is given, but we have to find out AD. So if we consider these two ratios together, let us put AC means AC by DC equals to AB by DE. If we write it like this, let us put the value. What is the value of AC? It is given in the question as AC equals to 24. You can pause the video and write the question and do it along with me. Maths is all about doing, not about just watching the video, but if you do it along with me, then you will understand the video properly. So if you want, you can pause the video and write the question and do it along with me, then only you will understand it properly. So AC value is 24. We have written the AC's value as 24. DC we are not given, we have to find out DC. And AB, how much AB is? AB is 9, DE is 3. 9 by 3. So what it will be? 3 3s are 9. So DC will be equals to, if we it will go here and it will come down, that means 24 by 3. 3 8s are 24. So DC is how much? It's 8. DC is 8. See, DC is this much. If this is 8 and AC, total AC is 24 given in the question, so AD is how much? AD will be equals to, see, AD will be equals to AC minus DC, isn't it? AC minus DC. So we'll write it here. AD equals to AC minus DC. Now what was AC? AC was 24. And what did we find? DC? DC as 8. So DC, AD will be coming as 16. 24 minus 8 is 16 centimeter. Don't forget to give the unit centimeter, because all the units are given in centimeter. You have to write it, otherwise you can lose 1 marks. Okay, so AD is 16 centimeter. Now next is basic proportionality theorem. What is basic proportionality theorem? It is also called Thales theorem. Okay, basic proportionality theorem, what it is saying, let us read the statement of the theorem. It is telling that if a line is drawn parallel to one side of a triangle, see, in a triangle, this is the triangle, okay, this is the triangle. If a line is drawn parallel to one side, this is one side, we can also draw it like this, a triangle. Suppose this side we want to make parallel, then this is the line. If a line is drawn parallel to one side of a triangle, intersecting the other two sides, these are the other two sides, it is intersecting here and here. In this case it is intersecting this point and this point, that is D and E, intersecting the other two sides in distinct points, that is here in this case D and E. Then the other two sides means this side and this side, are divided in the same ratio. Means what is telling? it is saying that if a line is drawn parallel to one side of a triangle, then AD by DB, what we have to prove is this, the meaning of this line, the other two sides are divided in the same ratio. Other two sides are divided in the same ratio means this is the other two sides, this is one side and this is another side. They are divided by these two distinct points in the same ratio. Like, to prove what we have to prove, it is AD by DB. AD by DB equals to AE by EC. So what is Thales theorem or basic proportionality theorem? It is nothing but, if in this case, see here, if this is a triangle, or also like this, if this is a triangle and if this is the parallel side and this is the parallel, this is the line which is cutting the other two sides in two distinct points. Suppose this is D and E and this is A, B, C. Then DE is parallel to AC. Then BE by EC will be equals to BD by DA. This portion by this portion, this portion by this portion. This is only basic proportionality theorem. I am not including the proof of this theorem in this video. I think proof is given in the book. The theorem's basic thing is necessary. That is, when you are given one triangle and if the any line is cutting the other two sides in like this, and this line is parallel to the third side, then it generally happens what? AD by DB equals to AE by AC, means this portion by this portion will be equal to this portion by this portion. This application is important, okay? So I am not including the proof, but I will include few sums regarding this theorem. I am not including the proof, but I will explain this one, because if you are given a triangle like this, and now why this is this by this equal to this by this, because if we consider the two triangles ABC and ADE, see here this triangle ABC and AD, this smaller triangle and the full triangle ABC. See, since this is parallel to this angle will be equal to this angle, corresponding angles, and again this angle will be equal to this angle, and this is the common. So by angle property, these two triangles are similar, and when two triangles are similar, the corresponding sides are proportional to each other, isn't it? So by that way we can prove that AD by DB equals to AE by EC. The converse of the Thales theorem is telling that if this AD by DB equals to AE by EC, then DE will be parallel to BC. This is the side which is cutting the other two sides. It will be parallel to this. Means Thales theorem is telling that if DE is parallel to BC, then these ratios are equal. That is AD by DB equals to AE by EC. And the converse theorem is telling that if AD by DB and AE by EC are equal, and it is not given this are parallel, if AD by DB equals to AE by EC, then DE is parallel to BC. This is the converse of Thales theorem. Now I am considering one question which is based on Thales theorem, converse of Thales theorem. In ABC triangle, see here this triangle is ABC, D and E, see this is the triangle ABC, D and E are points on the side AB and BC, AB and AC respectively. Then we have to find out whether DE is parallel to BC or not. Now in converse theorem, what we have learned? In the converse theorem, we have learned that this DE and BC will be parallel only if AD by DB, means this portion by this portion, will be equals to AE by EC, isn't it? If this ratio is equal, then only DE will be parallel to BC. Just now in the converse of the Thales theorem, we have learned if these two ratios are equal, then only DE will be parallel to BC. So in this question, the values are given, AD is given and BD is given. AE is given, but AC is given. So from AC, we need to find out EC. What will be EC? Sorry. EC will be equals to AC minus AE. What is AC given? AC is 10 centimeter and AE is 4. So it's coming as 6 centimeters. So what is EC? This portion is 6. Now I will check that AD by DB is equals to AE by EC or not. Let's check AD by DB. What is AD? AD is 3. What is DB or BD? BD is 4.5. Multiplying both numerator and denominator to remove the decimal. By 10 we are multiplying. So it's coming as 30 in the numerator, and in the denominator the point gets removed and it becomes 45 if we multiply it by 10. So cancel out by 15. 15 to the 30 and 15 3 is a 45. So it's coming as 2 by 3. Now AE by EC. Let us check what is AE by EC. What is AE? AE is given in the question, it is 4, and EC we just took it out as 6. So cancel it out by 2. 2 to the 4, 2 3 is a 6. So yes, it is coming as 2 by 3. So both AD by DB equals to AE by EC. Both are coming as 2 by 3. So we can write it as AD by DB equals to AE by EC. So by converse of the theorem, Thales theorem, we can say that since they are equal, we can say that, which implies DE will be parallel to BC. DE will be parallel to BC by converse of, you can write it here, by converse of Thales theorem. Okay, I hope you understood this question. How to apply the Thales theorem, how to understand. Okay, and if you understand the theorem properly, how it is, how just nothing, it's very easy. Triangles, many of the students find it very difficult, but actually it's not that difficult. If you understand the theorems properly, go through the examples of your book. First of all, go through the examples. If you can't understand the example what it is, because sometimes in examples there is step jump, so you do it in your copy and do it yourself. Actually see which theorem, what is the reason given, why it is applying. If you think about it properly, then, and if you can cope up with the examples, understand the examples properly, the exercise will be just very easy to solve, and it's nothing very scary, this triangle chapter. So I hope you understood this chapter. If you want me to include more sums, there is another part is there, that is map and real figures, that is application of maps and models. If you want me to consider those sums, please let me know in the comment section. I will include more sums of similarity in a new video. And so up to this, I am closing this video. I hope you like this video. If you understood the video, please share it, like it, and subscribe to my channel. Thank you.